Today we will cover part 2 of the Hess's Law Lab. The procedure is found on page 4 of the lab handout. So today we will review the procedure. I will give you all the data that you need to then do the calculations and the graphing. So that's what we're going to cover in today's lesson. So we're using the same setup that we used for calculating with the calorimeter in part 1. And we're going to use that same setup to do all 3 of the reactions, the acid-base reactions that you learned about in the pre-lab. So I'm going to go through each reaction and talk to you about what you would actually be doing if you were to do this in our classroom and lab. So we'll just take some time for you to kind of see what the procedure is and for it to make a little bit of sense for you, and then I will give you all of the data on the next slide. So this is reaction 1, and in reaction 1 you're going to be mixing 2 molar hydrochloric acid with 2 molar sodium hydroxide. It's going to form sodium chloride salt and liquid water. So the first thing that you should do is put that magnetic stirring bar into the calorimeter, because after you add the hydrochloric acid you want to start stirring so that when you add the next solution it will start mixing right away. So first things first, into the calorimeter we have 50 mils of 2 molar HCl, and this is at 22.9 degrees C. That's our initial temperature, room temperature, when we add this solution. So that's the first thing that you're going to add. Now you will start the magnetic stir to be stirring the hydrochloric acid that's in there, and then you're going to add in 2 molar, let me tell you how much, 50 milliliters of 2 molar sodium hydroxide. And this too is at room temperature, so that initial temperature of the solution is going to be 22.9 degrees C. You're going to continue stirring, and then you're going to record the temperature after 20 seconds, and then every 20 seconds for 3 minutes. So it's very similar to determining the heat capacity of the calorimeter. We did the exact same thing, except we were doing 2 different temperature waters. So here we're looking at an acid-base reaction that we're going to see a temperature change, either increase or decrease, depending on the reaction. And on the next slide I'll give you all of that data. So that's reaction 1. So here's all the data that we collected for the reaction number 1, which is the hydrochloric acid and sodium hydroxide. So I would pause the video and copy this data into your data table. That data table is found on page 5 of your lab handout. So now we're looking at reaction 2. We're going to be mixing a 2 molar solution of ammonium chloride with a 2 molar solution of sodium hydroxide. This procedure would actually be done in the fume hood because we are going to be forming ammonia as one of the products, as well as sodium chloride salt and liquid water. So because of the ammonia fumes, we would want to do this in a fume hood so that we're not breathing in those fumes. They can hurt your lungs and make it a little bit hard for you to breathe. So let's look at what is going to happen in this lab, or in this reaction. So again, we are going to add solutions. We want to make sure that stir bar is in the calorimeter. We're using the exact same calorimeter that we used for the last reaction. We just cleaned it out and dried it to start. So we're going to add 50 mils of the ammonium chloride. It's 2 molar ammonium chloride solution. I'll write this over here. And the temperature again is still at 22.9. The temperature of our lab has not changed, which makes sense. The other thing that we're going to add to this is our 50 mils of our 2 molar sodium hydroxide solution, and this is also at 22.9 degrees C. So that's our initial temperatures. And we are going to make sure that we had started that magnetic stirring going on before we add that sodium hydroxide. Then once we add the sodium hydroxide in, everything is stirring. Again, we're going to record the first temperature at 20 seconds, and then we're going to record temperatures every 20 seconds for 3 minutes. So on the next slide, again, I will be giving you all of the data that was collected for this particular experiment. So here's the data that was collected for reaction number 2. The data table that you're going to copy this information on is on page 6 of your lab handout, and it might be a good idea to pause the video so that you can record all of this data. As you can see, the temperature rose slightly, and then it stayed at 24.1 degrees C for the whole entire three minutes. So pretty easy data table to write out. So our third and final reaction, we're going to be using ammonia, and hydrochloric acid, and it's going to form the sodium chloride salt, and this is the third and final reaction. This one would also be done in the fume hood. Ammonia is actually, we're going to be using ammonium hydroxide, so it's the same thing though. Ammonium hydroxide and ammonia are the same thing. And again, it's 2 molar solutions of both of these things, the acid and also the ammonia, and 50 mils of it. So we're going to do the exact same thing. Add in our 50 mils of 2 molar ammonium hydroxide, and it's going to be at 22.9 degrees C, just like all the rest, because again, our room temperature doesn't change when we're doing this experiment. It's going to stay fairly consistent. You want to make sure your magnetic stir bar is in the calorimeter that was cleaned and dried before we used it for the third reaction, the same calorimeter, and you will begin stirring. Once you have it stirring, you're going to add your 50 mils of 2 molar HCl, and again at 22.9 degrees C, and you are going to record the first temperature at 20 seconds, and then you'll record every 20 seconds for 3 minutes, you'll record the temperature. And again, you'll notice that you have a thermometer going through the styrofoam cover of your calorimeter, and you'll be recording those temperatures. And if I didn't mention, this would also be done in the fume hood because of the ammonia fumes. Again, they're hazardous to our lungs, and so we don't want to be breathing those fumes in. And here's the data that was collected for reaction 3. Again, this data table can be found on page 6 of the lab handout, and you may want to pause the video and collect all of the data that is on this particular slide. Now the last thing that we need to do is just kind of review the part 2 calculations. I'll just highlight some of the things that you want to be aware of and make sure that you include in your calculation section of your lab report. So the first question wants you to do some graphing. So there's a couple ways that you could prepare your graphs. I know a lot of you are tech savvy, so I'm really open to however you feel comfortable doing this. If you want to do graphs using Excel or some kind of program like that, that's fine too. And then import that into your lab report. That works for me. If you want to take a screenshot of the graph that was given to you for the calorimeter section in part 1, you just want to make sure that if you screenshot that, you have to change the temperatures. The time axis can stay, the x-axis can stay the same because it's over 3 minutes, but your temperatures would have to be changed to the correct temperature range. So there's lots of ways that you can prepare a graph. You can use the graph paper in Notability and just do it right in Notability if that's how you're writing your lab report. Again, I'm going to kind of leave that up to you. but just make sure that you have the graphs in there because that is part of the lab report. And the other thing that you want to make sure that you do with your graphing is extrapolate that line back so that you can find the T mix and record that information, because you'll be needing that for some of your calculations in number 2. So graphing and recording values for T mix are what you're going to be doing in number 1. In number 2, you're going to be calculating the Q value of the reaction, and here you're going to take into account the calorimeter, the heat absorbed by the calorimeter. Now again, I'm not really sure why we have this typo here. They spelled it correctly here, but not in the equation. So I'm not really sure what's going on there. I didn't type this. This is a experiment that I get from Flynn. So we're not using a colorimeter, we're using a calorimeter. I just want to point that out. So, and know that although I do make mistakes, I didn't make that one. Okay, so you're going to calculate your Q of reaction. It's very specific here on what you have to plug into this equation. So read through that. If you have questions, please ask. It's really not that much different than what you have done before and what you have seen in the pre-lab. I want you to also take into account the density of the solution. They're giving that to you. They're also giving you the specific heat of all the solutions, being very much the same as water because they're aqueous solutions, and the molarity is pretty low. So we can use that, the 4.184. Again, if you want to use 4.18, that's fine too. It doesn't matter to me. Just know that Q is given to you, or when you calculate it's going to be in joules. So your final answer here will be in joules. When you look at number 3, you're going to be converting that to kilojoules. So be mindful of that. And record that Q of reaction on your data table. There's a little spot for that on all the data tables. And you're going to do this for each reaction. So you should have 3 calculations that you're doing. In your analysis section or calculation section of your lab report, you're going to be putting these calculations in there. And number 3, you're calculating the enthalpy change. So here you're calculating the delta H of the reaction. So you're going to take that Q value that you found in number 2, you're going to convert the joules to kilojoules, and you're going to also make sure that you are calculating per mole, kilojoules per mole. This calculation is similar to the pre-lab question that asks you to determine the kilojoules per mole for the reactions. If you look back at all the reactions, all the coefficients are 1, and all the solutions are at 2 molar. So it's going to be pretty easy to calculate the moles that you need for the reaction, and divide your kilojoules by mole, and then you're going to record that delta H into the data table. So you have 3 different delta H's for the reaction. Those delta H's are important because that's what you need when you're going to be calculating your overall delta H for the reaction. So this information is going to be used in further calculations later on. So that's just a quick review of those calculations. I'm not going to work out any of the calculations because I think they're self-explanatory. However, if you have some questions about the calculations, please reach out to me. You can email me or you can ask in the forum on the class page. Either way is fine for me. So any questions, please ask. So I just want to remind you that I recommend working through the graphs and the calculations as they're done with you in the video lesson, because all of this information is then going to be prepared and ready for you to put into your final lab report. So although I'm not grading each of the assignments that I'm giving for the video lessons, it is recommended that you kind of stay on top of the work so that it's easier to write up your final report and it won't take you as long to do that. So my recommendation is that you take some time to work on the Part 2 data tables and calculations for this video lesson. I do give you a day this week to work on part 1 and part 2 calculations, so you do get some time or kind of a day off this week where you can kind of get ahead with that lab report however you want to work that kind of free day to work on your calculations and your graphing and things of that nature. Ask me questions on that day. So I'm here if you need help. Now, our next lesson, or next video, is going to be verifying Hess's law. So it'll be important for you to have your data up to date so it'll make sense when I go through the calculations for that. So I'll see you in our next lesson. I hope this was helpful, and have a great day.